Iron is an element. Is iron one of the 7 diatomics?
No.
It does not matter that it says iron 3. It is not one of the 7 diatomics. It does not get a subscript, period. Okay? The 3 is irrelevant. The only reason you need the 3 is to know that it's positive 3, so you know to switch it with who for the other side.
Aluminum.
That's right. That's the only reason you need to know it's a 3. But in terms of a subscript here, it does not get a subscript. Okay? That's its only function. So it gets no subscript. So who is switching with who here? Well, first of all, do y'all know what single displacement? Because I'm just assuming you know that. So we all know what single displacement. Okay, a little bit. Okay, how do you know it's single displacement? Since Ashai said a little bit. What is this right here?
Compound.
That's a compound, and this is a what? That's how we know it's single displacement, because it's a compound plus an element. Okay? So, if it's a compound plus an element, we switch the 2 elements that have the same sign. So, which 2 elements have the same sign? That's why we're going to switch Fe and Al. All right, so Fe is going to wind up with who? SO4, and Al is going to wind up by itself. Now, the only number that got to come across the arrow is the 4 because it's part of the what? Polyatomic ion. All right, now, this is a what?
This is a
Compound. So we got to do what to it every time? Crisscross. Well, I'm looking up oxidation numbers. Plus.
3 minus 2 -2.
So 2 comes down, 3 comes down. Aluminum is by itself. Is it one of the 7 diatomics? It gets nothing. Okay? So, I'm going to erase these oxidation numbers out. All we have left is the balance. The SO4s each have what on them? So they're done. Fe has a, and aluminum has a, so it's balanced. All right. Next. 4. All right. 4 says aluminum sulfate. That's what I just did. Pick something else. 10 on the front. All right. 10 on the front says FB 3 PO4 with a 5 plus MN MnO4 with a 7. All right. What kind is this, Shatoria? Can you tell me that? Okay. She knows, Shatoria.
I didn't.
You've been cloned. You just didn't know it. All right. Do you understand why she said double displacement? Okay. This is a compound, and this is a compound. Because both of them are compounds. Compound plus compound makes it double displacement. Okay? So now we're going to look up everybody's oxidation number. Now, we don't have to use our sheet. We're going backwards crisscross. This 5 came from where? So SB. That 3 came from where? That 7 came from. And that 1 came from. Okay. So who's going to switch with who? Okay. So SB is going to be with who on my side? MnO4. And then Mn. Oh, okay. Gonna be there. So now the only reason I brought the 4s over is they're in the parentheses. Now we got to put all the numbers back in again. So the same numbers I have at the top, we're going to put in. So SB had what number at the top? And MnO4 had what number at the top? MnO4 had what? MnO4 had, okay. Men had what number at the top? And PO4 had what number at the top? Okay. So then we're going to crisscross. 5 comes down. 1 comes down. 7 comes down. 3 thermostats. With me on how I did that? Okay, so let me get rid of all these so you don't have any extra numbers floating around. And then we're going to balance. All right, so you want to balance first. MnO4? How many MnO4s are here? Right here. So, if you got 5 here, or 5 here and 7 here, we can put a 7, and we can put a 5 to make 35. That makes how many Mn? Can we get 7 here? No. All right, so we can try the other Mn, like you said. There's how many here? How many here? There's 1, so we can put 3 here, and that makes how many Mn? Can we make 21? Okay, so that's not going to work either. So we've ruled out this Mn and that Mn. It's something different. PO4. All right, how many PO4s are here? All right, how many here? So we could try that whole 7 and 5 thing. See what happens. And go to 35. So how many SPs did I make?
Oh,
So can I get 21 SPs? How many here? So if I write 21, 21 times 1 is 21. So that might work. Okay? So you're going to need a calculator probably. How many MnO4s did I make? You got a calculator. Why are you multiplying by longhand? Go get a calculator.
it's what
Okay, so 105. So can we get 105 here if we got 7? How do you know you don't have a calculator? Instead of just telling me no. I asked her if 7 was going to 105, and she just said no. Because she doesn't have a calculator, so now she's dividing longhand. Yes, how many times?
Oh, I like your book going on.
Thank you.
Oh, is there another one?
Yeah.
One is thank you.
That one is
Oh, I never liked them.
Yeah.
Yeah.
That's correct. Okay. Question. 7. All right, one more because we're going to need to move on. 6 on the back. All right. So 6 on the back says C14, H30 plus oxygen. How do I write oxygen? It's O2. I don't know who said HOH. All right. HOH would be what compound? Water. All right. O2 is oxygen. Now, sometimes when people see this initially on the test, they see this as an element and a compound, and they want to try to do single displacement. If you see that, and you start thinking, what are the oxidation numbers for C and H, and you see that 14 and 30, that will lead you down a path to, oh my God, I don't know the oxidation numbers. Like I told you the other day, if you start down that path and you have no idea what the oxidation numbers are, that should start to tell you I'm doing something wrong. It's not single displacement, right? So once you figure that out, you will recognize it as what kind of reaction. So what are the two products? CO2 plus H2O. Now, once you get there, the biggest problem is probably what Jordan said a while ago, is while I can write the products, it's the balance. So, how many C's are here? So, I need 14 C's here. How many H's are there? So, I have how many H's here? So, 15 times 2 will make 30. Now, the problem comes in with the O. Use the calculator. 14 times 2 is plus 15. And 15 times 1 is 15. So 28 plus 15 is what? Y'all don't even sound like y'all have the same number. I'm thinking 38 plus 5 is 43 myself. Okay. Now, from there, can we get 43 O's right here? No. So, what did I tell y'all to do if you got an odd number of O's? So come back to the front and put a 2 on that very first compound. So, because now it's going to be an even number. So 2 times 14 makes what? So we need 28C. 2 times 30 makes what? 60. So I need 60 H's. So 2 times 30 makes 60 H's. So now 2 times 28 is
56.
56.
Yeah.
Why do it with a calculator? Plus 30
It's on my calculator right here, but
is 86. Okay? So 43 times 2 is 86. Okay? This is why I tell y'all if you want a calculator on the test Monday, you got a calculator. Question. No, you're not. You're going to get a real calculator. I told y'all I have trust issues. Questions about how to balance that? Let me tell you the truth. Because I've done it for a long time. All right, you need your blue reference sheet. And you need to turn over to the next side, page 7. Yep, we got to do the last 2 sections of the test. What? Last page, last 4 questions. All right, we're going to talk about the activity series for the probably pretty close to the rest of the day.
what is that?
Yep.
I don't
Those of
know.
you like titles, you title the activity series.
I thought we were actually doing like an activity.
Yeah. We are not.
I hadn't believed we were.
I thought we were doing that rock around.
Yeah, I thought.
Yep.
No, not that thing. I'm sorry. At this point, you saw. Anyone else think? I have one thing. Okay, so.
All right, everybody got it? Another note? All right, the activity series tells us the order in which elements react. Okay? It tells us the order in which elements react. Now, we've written lots of equations in the last few weeks. Do all of these reactions occur? No. I have made up lots of reactions. Not all of them occur. So the activity series is going to tell us which reactions do occur and which reactions do not occur. Now, in order to use the activity series, there are 2 ways to read the activity series. Now, the first way, okay, has arrows. If you have what? An acid or oxygen in the equation, you use arrows. Okay? You use arrows on the activity series to determine if the reaction occurs. But again, that's only if you have what three things. And this is all in the activity series. You don't have to memorize this. If you have water, if you have acid, or if you have oxygen, you use the arrow. And this is marked on the activity series. Now, the problem is, does every reaction have water and acid or oxygen? No, of course not. And again, this is a first year class. So we're only doing some basics.
What would you say is the hardest part of podcast?
I can tell you where the lowest scoring test is. I don't know what the filing cabinet. I don't know what the filing cabinet. Not the filing cabinet. Somebody wants a very large table. Oh no, they're giving up a very large table.
How much?
Now apparently her class is growing fake, let's tell you. Yeah, to make it. Apparently she likes doing that. Alright, so, if I got it with it? So, how can we use this chart other than reading these arrows? The second way is if there isn't any water, acid, or oxygen. All right, the element that is by itself, or by itself, I mean alone. Okay, the one that's alone has to be above. Okay, it has to be above the element it's displacing. So we're going to look at where it actually is in the chart. So the element that's alone must be above.
Oh, I'm good.
Yes.
We don't have our observation system.
Yes. We're on day 27. No, 28 today. So we're almost at 6 weeks. So after we leave week 12, the polyatomic ions you have to use on your blue reference. The singular elements that you've been using on the right-hand side or left-hand side of that chart, you will be able to find using the periodic table by week 12. Because I will talk to you skills used on the periodic table, because we will already use to learn how to use the periodic table. Some of you will do very well with the periodic table, some of you will not. Which is where I was supposed to answer a question I was reading back to Mel. You asked what was the hardest topic. I was going to say I can tell you where the lowest point that typically is. It's typically the periodic table and bonding. Do I think it's the hardest topic? No. Is it the lowest scoring test? Yes. Why? I have no idea.
Don't think about it.
No, I'm thinking. Typically bonding is probably harder for a lot of people. You think this is bad? Bonding is probably a lot like that. It's very rules driven. So it's probably a lot like it. A lot of you won't like the periodic table because it's got a lot of rules. A lot of you will come in and tell me you don't get it when you come back to next step. For example, I'll ask where the biggest element is on the periodic table. You'll have to know that it's the bottom left. So when I give you 4 elements and ask you which one is bigger, if you can't tell me that the bottom left is bigger, you can't look at the 4 elements and tell me which one's biggest if you don't know the bottom left. Ionization energy is bigger at the top right. You can't tell me that, so you will figure out who has the highest ionization. So there's the memorization that has to go with that. So that's the downside of the periodic table. Yeah.
That's what I could do.
Nope, we're not going to memorize anything to begin with numbers.
No, it's more like,
Atomic mass, nope, has nothing to do with it. Has to do with outer shell electrons.
I'm not talking about the college.
Talking about valence electrons.
Oh, I currently. Why?
I have no idea.
I actually like to do it work with the person.
It doesn't. I mean, in all honesty, this is a useless course for the vast majority of you. I mean, physical science would be a much better course for well-rounded. It's more useful. I mean, the stuff I teach in physical science is more useful. Organic is the study of carbon compounds. All right, on your reference table, you get to write again. No, you get to write on it. Now, again, by January, you will know these things. But right now, since you probably don't, on your blue reference sheet, you may write where it says replace hydrogen with cold water, H2O with the symbol L behind it. You may write that because I have to use symbols in these equations to differentiate between replace hydrogen from cold water and replace hydrogen from steam, okay? You have to be able to tell the difference between cold water and steam. Cold water is going to be given the symbol L for liquid, and steam is going to be given a G for gas.
So is that plus H2O?
Plus H2O.
What's that thing?
It's an L.
Oh,
Here.
okay.
It looks like an I now, but there. Looks like a 1. But L's are not written as capital L. They're not written as capital L's in the symbol. I'm not writing a capital L to make you happy. Just to torment you.
Y'all don't put a little line up of your eyes. No, why not they come it out?
That's what I'm doing. Because there's no letter CI on the periodic table, so the rest of us know it's CL.
No, like, carbon ion.
Yeah, I know. There is no CI like that. Because if you want CI, we write it like that. So if CL is chlorine, we don't write CI, it means C iodine. Carbon iodine, we don't write it that way. We write it this way. We do. You should do. Alright? Now, acids start with hydrogen. They all start with hydrogen. You should learn that in another science class. Now, if you look at your acids, they should all start with H. If you look on your oxidation sheet. So I wrote an example there. HCl is an acid. You don't have to write that part, but if you did, it's fine. And then plus H2O is an oxide. Now, I pointed this out yesterday to fourth period, and they were like, well, Paul, that makes so much sense. So let me do it here before you accuse me of teaching them something I didn't teach y'all. They were complaining about their 4 acids and trying to memorize them. So when you're trying to learn phosphoric acid, if I told you that it was hydrogen with a phosphate ion, and you can't get the formula right in your head, hydrogen, don't write this on your blue sheet either. Hydrogen and phosphate. Hydrogen has what oxidation number? Hydrogen is a +1. Phosphate has what now? Has a 3. Bring your 3 down, bring your 1 down. There's your phosphoric acid. Okay? If you were doing nitric acid, nitric is hydrogen and nitrate. Nitrate has a -1. So the two ones are going to cancel out. So it's nitric acid. Or if you had sulfuric acid, it's hydrogen and sulfate.
We'll get the ion on.
Okay? Just a thought if you're struggling to memorize your acid. Nitric is nitrate, sulfate is sulfuric, phosphate is phosphor. Okay?
What?
Mm-hmm. Oh, that was a G. I just accidentally erased it when I was talking about the acid.
I saw the one.
All right. So let's say this is our example. All right, zinc plus water is a liquid. And you want to figure out if this reaction occurs. Okay? First of all, rule 1. Do you have water as a liquid? Or any type of water? Do you have an acid or do you have oxygen? If so, we're reading arrows. Do you have water, acid, or oxygen? Okay. Because you have this, okay, we're reading arrows. Now, you cannot draw all over your blue chart. Well, I have these charts all stuck in my presentation, so I can draw all over them. Okay? Now, it said H2O is a liquid, right? H2O is a liquid right here. If zinc falls in this arrow that goes with H2O as a liquid, then the reaction occurs. Do you see the arrow on your paper? Okay. Is zinc in the range of that arrow on your blue sheet? And you can look at your blue sheet if you want. You can even draw the lines if it makes you happy. Okay. Is zinc in the range of that first arrow? No. Then all we write here is no reaction. If we put zinc metal in water, nothing happens. It sinks to the bottom and sits there. Absolutely nothing is going to happen with that metal. It doesn't do anything. Okay? Does nothing. Okay? Again, what can you tell me about this? Do we have water? Do we have an acid? And do we have oxygen? Gotcha. So again, we're reading the arrow. Now this time, the oxygen arrow is this arrow. Okay? Everybody see the difference? Oxygen is here. That is this arrow. That means this whole big section is the arrow. Is 10 in that section.
Oh.
Everybody see it? Right there. 10 is in that section. Because this arrow is the oxide arrow. So it's 10 in that section. Gold, silver, and platinum are pretty much unreactive. Okay? These right here are pretty much unreactive. They will react for some things, but it's pretty much limited. I'd rather you do. Okay? I said you could draw the lines in. This line, that line, that line, that line, that line. No, you don't. All right. So if SN was a yes, okay, so if this was a yes, what kind of reaction is it?
I thought. Oh,
Thank God. Thinking we need to start looking for the land of Wyoming again. All right? Yes. It is synthesis. So if it is synthesis, what should we do with these two elements? Combine. Okay? So we're going to put them together. And we're going to make an SNO. Now, this is one of the elements that has more than one oxidation number. Did I tell you which one to use? No, it's got a 2 and a 4. Which one do you want to use? I'll let y'all pick.
let's use the 4. Sure.
It doesn't matter. We can use the 2 or the 4. If this was a test and I didn't tell you, what would your options be? And I would grade either one. Okay? So if we use the +2 and the -2, they'd cancel out. And that would be fine. If you were the people who said, let me use the 4, use that +4 and -2, you'd need to make sure you reduced and had SNO2 as your answer choice. Okay? It doesn't make any difference to me. Either answer would be fine. And then you'd balance accordingly, depending on which one you chose to use in the answer. Of course, if you picked SNO2, yours would already be balanced. If you picked SNO, you would need to balance that 2 2s in your reaction. Okay? Any questions about that? All right. I'll have that. Another chart. All right. So let's say this one. Cu plus HCl. Do you have any water? You have an acid.
Yes.
Okay. So this time again, we're going to use the arrow. So if I flip back over to my chart, this time I'm reading this one. So this is my acid arrow. So I'm looking to see if copper, what's on direction? Copper, up with you. Copper is in that range. Is copper in that range?
No.
No. So you're right. No reaction. Everybody okay with how to figure out if it yes it occurs or no it doesn't? Alexa's a no. This arrow right here is for water. If it says H2O is a liquid,
Can I either H on the fill out the first one?
Okay. If it says H2O is a liquid, Alexa, you only read this section. It has to be from this line above to react to water as a liquid. If it says water is a gas, it has to fit from here up, from there to there. It would have to be from that line and above. No, you would not. It has to be from the line up. So for a gas, or sorry, acid, which we just said, would have to go from here up. It's not just here to here. Yes. Does that make sense? Okay. Everybody else with us? Okay, so we just said copper plus an acid, right? So an acid is everything in this range. So is copper in that range? No. So here, we're going to write what then? No reaction. It doesn't occur. So what about Mg plus water? Okay.
Oh, and it has a reaction.
Okay, so if we produce back, it's a gas this time, right? So that would be this range. Is Mg in this range?
Yes.
All right, I heard yes. All right, so, and I'll be honest, on the test, you get a certain amount of points for understanding that it's a yes. You get your second amount of points for predicting correctly. So you get some points for being able to tell me yes from reading the chart correctly. Okay? So if you tell me no and predict nothing, you lose all 4 points. That's just the way it works.
Can you write yes and no on the?
You can. You don't have to, but you can. If you predict, I assume you tell me it's yes. Okay? Now, what kind of reaction is it? Okay? So, what are we going to do to get our problem? Okay? Anything else?
Crisscross applesauce.
Huh?
Oh.
What, Queen? It's not something. There is something I'm hoping you're going to tell me before we just start.
It's B on the.
It's the exception.
Because it has water. Yeah, water plus.
That's what I wanted you to tell me. This is the metal plus water, but I wanted you to either tell me it's water written as HOH because it's the metal plus water, or you can use the format on the reference table and recognize that you need to use the M plus H2O becomes MOH plus H2. I don't care which way you do it, but this is the one that you got to recognize. It's the metal plus water. Okay? So, whichever way you do it, you're going to get Mg with OH plus H2. And then you got a compound. So what do you got to do with that compound? Crisscross. So Mg is plus 2. And then OH is minus 1. Bring our 2 down. Bring our 1 down. Question. And then you would balance. You need a 2 in front of water.
But if you keep it in
No, you still have the wrong number of H's. Because even if you left it as H2O, you still got 2 H's and 1 O. What did you say, Alexa? Where did I get 1 from? Where did I get this 2 from? Because Mg is a plus 2 and OH is a minus 1. It's a compound, so we always have to crisscross our oxidation number. You call the oxidation number what? Okay. All right. Now, how is this one different?
Oh, the quality comment.
Okay. What do I not have here that I had in the last 4 we did? Okay, I had to say, do I have water? Do I have an acid? Do I have oxygen? No. Okay. In this one, there is no water, acid, or oxygen, which means we will not read the arrows. Okay? We're not reading any arrows this time because there's no water, there's no acid, there's no oxygen. This is where we wrote down step 2 or part 2 of those notes. Okay? So if I cruise back, catch up with me, we're going to cruise back to what we wrote down. We'll not read the arrows. All right, if there's no water, acid, or oxygen, the element that's alone or by itself, all right, who's ever alone or by itself has to be where? Has to be above the element it's displacing. Okay? Whoever's alone or by itself has to be above whoever it's displacing. Okay? So we got to find the oxidation numbers to see who's displacing who. All right, so let's look up CD. All right, CD is cadmium. Is that one of the reference? +2. All right, lead has what oxidation number?
That's multiple options.
Okay, +2 because of that right there, right? Okay. Nitrate is -1. So, given that information, who is displacing who? Who is by itself? So CD, being the one that's alone, has to be big enough and strong enough to knock who out of the compound? Lead. So CD has to be big enough to knock lead out of its position on that compound. Okay? So, going back to the chart, is CD above lead?
Oh, yes.
Yes. Okay? So, CD must be above lead. Okay? Because CD is the one that's alone. CD has to be above lead. It has to be high enough in the chart to knock the PB out of that compound. It wouldn't matter because they're both positive. The two positives are what switch, right? The numbers themselves are irrelevant. The positive number is switching with a positive number.
So when you say big enough, strong enough that when you give it to God,
That's correct. Okay? So, will this occur? Is CD above PB? Yes. Since CD is above, the answer is yes. Because CD is above PB, the answer is yes. That's all it's about. Is CD above PB? It could be one spot, and the answer is yes. So, what kind of reaction is this? Okay, so if it's single displacement, what are we getting over here? CD, NO3, and plus PB. All right, is PB getting any subscripts on it? No, because it's not 1 to 7. What are we doing for the compound? So +2 and -1, bring our 2 down. Okay? It was, so I wasn't going to point that out. I figured you'd get there on your own. All right, let's do the next one. This one always creates issues. So Ki plus CO2. What can y'all tell me about K? All right. Oh, let me ask you this. Do you have any water?
No, I'm the big.
In all the years I've done this, you'd be the first one to tell me, yeah, you have water. Oh, that's good.
Wait, I listened to
I want to know if I had any water in that equation. Y'all got any water? It's in there. Okay. I'm glad y'all do. Stay hydrated today. It's important.
Oh, yeah.
All right. In the reaction on the board. It's important. Hydrate. Okay. So in the reaction on the board, people, do we have any water?
No.
Do we have any acids?
No.
Do we have any oxygen? No. Okay. So clearly we can't read the arrows. Okay? So, no arrows. So we got to figure out who's got to be above who, right? Okay. So now we're going to use the oxidation number. Double that one. I can erase it. So K is the oxidation number for potassium would be, iodine would be, and chlorine would be. Okay. So who would be displacing who?
Iodine or chlorine?
Chlorine and iodine. Now, thinking about the steps and the rules that we just talked about, who has to be above who?
So,
Okay, the one by itself or alone. All right, so Cl must be above who? Who's it displacing?
iodine.
Iodine. Okay, so chlorine must be above iodine. All right, so if I cruise back over here, and we look at the chart,
It's a halogene.
It's not on there.
this is what people struggle with. I get that answer a lot.
Go up, let me see it, Bob.
Now,
Halogen.
so that we're not like Jordan,
Oh,
all right, because we get it a lot. It's okay, Jordan. People do it all the time. They're so focused on no that they miss the activity series for the halogen. Okay, it's okay. We can do it all the time. Now, the activity series for the halogen, all right, only have the 4 halogens, the same ones, the 5 clear brownie blottos that we said were -1. Is chlorine above iodine?
Yeah.
Yes. So, the answer is yes. So, what kind of reaction is that? So, what are my 2 products?
KCl plus I2.
Okay, I2 because it is, and K and Cl are both. So those will cancel out. Pressure. Fabulous.
wait, what is that?
Okay, so we're going to put 2's where? Question. You think you can practice? Let's see if I have it in this or if I got to pull up another file. I got to pull up another file. All right, let me get rid of this. No. No. Maybe you drink some water over there. That'll teach me to only ask partial questions.
Oh, the neighborhood Walmart. Big Walmart. Big Walmart.
I didn't think I like.
Talking about this short, it's gonna fix
Hey, what?
All right. Find last night's homework sheet.
Oh.
Last night's homework sheet.
You like gone like you wasn't
Oh, can I see anything?
Now, hey, they took corrective lenses off mine on Tuesday. I couldn't read anything on the right-hand side of that thing. It was a tan box. I couldn't see any of the letters. And the dude said, read the middle of line 6. It's like, reading those numbers either, but I guess roll enough and took it off. So I was going down the road on the way home, and somebody said, Mom, what's those signs say? Take your glasses off. Tell me what it says. I don't have any idea. They took corrective lenses off my driver's license for 8 years.
Wow.
Wow. I want to be a personality. You just need an orange jumpsuit to go with that. Now, on your on your homework, I want you to do the remaining 6 on that page, and I want you to add those. Now, the remaining 6 on the page from last night's homework, I just want you to predict. I do not want you to use the activity series on last night's remaining 6, okay? Those 5, I want you to use the activity series on, okay? Does everybody understand the difference? These 5, I want you to use the activity series on. Do them on separate notebook pages, okay? The 6 that are left for homework on the last night's sheet, just predict. Don't use the activity series. Homework. What about my homework? Second. Several people are still struggling with homework. You can take a picture of that if you want while you're working on it. But this is the activity series part of homework. Yes, you want to work on it. This is the activity series. Now, you need to either write them down or take a picture of it. I don't care which. I would probably put it on a separate sheet of paper unless you think you can get it on last night's homework, but most of you probably can't squeeze on last night's homework. I can do it on, yeah, you can do it on your notes, that's fine.
What should I do?
Right?
I didn't hear.
It really is. No, they're not.
Really is.
If they had water in your reaction while ago, I said, do we have water? And one of them held up their bottle and said, it was full, I got water. I'm like, sweet baby Jesus. I'm talking about the reaction.
Okay, water.
Yeah, they have water. I can't fix that little dog.
I got water.
Hydrate.
You do it anyway.
I know they want. Oh, yeah. Wow. Okay,
What's it will be.
Mine was almost sweating and it was raining, so my hair was. I had to cut it away. I mean, I can't take them down. It's straight up. It's like a mile every day. It was raining, so my hair was like all like that.
Yeah.
I was like, I can't put it in a place. It's nice. I'm like, I don't know. Oh my God.
You can easily have done that homework, but it's 2 days old. It's single double twice. You can do it. Yes, one right there on my computer. I will not, I put everything that's from there, but I will be here next Monday, Wednesday, Thursday. I might have to cancel on one day for band, but I can be here 3 days. Will any of those days work for you? Yes. Okay. Yes. Very good stuff. All right, Amy, did you want one?
Was it like years to make up for that? Wow.
Oh, next week I should be here at least 3 days.
Okay.
Because I told you not staying after school for band is 1 to 2 days next week. And I'll see if I can get my mother-in-law to pick them up one.
Okay.
Because he can't seem to figure out which day to stay. Oh, I can't work with a short notice crap. Yeah, but you want to ask him about that one, because he went to a meeting with her last year. Talking about something, and he felt like he couldn't pick up. Hang on.